This is lesson 9-2 from the Algebra Readiness textbook. For today's lesson, you'll need your notes packet and a sharpened pencil. Begin today's lesson by trying both the check skills you'll need and the study guide problems, one that has 4 parts. Pause the video and come on back to compare your answers to mine. All right, so the first 4 problems here are review, in which you have to solve for the variable. In our first example, n plus 45 equals 180. Your first step is to isolate n by subtracting 45 from both sides, and you get n equals 135. In our second example, 75 plus x equals 90. Many of you like to switch that around, so the variable is first. X plus 75 equals 90. Then it's easy to see that your first step should be to subtract 75 from both sides. When you subtract 75 from both sides, you find out that x equals 15. In number 3, 3y equals 2y plus 90. The first thing that we notice is that there are two variables or two terms that have variables in them. We can't start solving until we add or subtract off one of the terms containing a variable. So we subtract 2y from both sides, and we end up with y equals 90. In our last example, I see another one where we have two variables. So we subtract off the variable a, and we're ending with a plus 15 equals 45. Then you subtract 15 from both sides to find out that the value of a is 30. All right, in this one, your job, given the diagram, is to name 3 points. I'm going to list all of the possible points, and you just need to choose 3 of them. Point B, point A, point D, point C, and point E are all points in this diagram. Letter B. Find or name 4 different segments. A segment is named by 2 endpoints. Now, I'm going to show you all of the possible answers, and you could write them in either order. So the order in this case doesn't matter. So you could have line segment BD or DB, AD or DA, line segment DE or ED, CD or DC, AC or CA, BE or EB. Write 2 other names for line AC. Now, to name a line, you can pick any 2 points on the line, and it'll name the same line. So in this case, I could have chosen AD or DA, or I could have chosen DC or CD. Either one of those is fine. The last one is naming 3 different rays. In this example, the order does matter. Your possible answers are BD, ray DE, ray DA, ray DC, or ray AC. In this lesson, you will learn to identify special pairs of angles. So the first vocabulary word we need to talk about is adjacent. Adjacent means next to. For example, the next to would mean to your left or to your right. So adjacent angles share a vertex and a side, but no points in their interior. So take a minute to write down that definition. Notice that this is the common side. It's kind of like they're overlapping. I like to think of it as an overlapping side. So I've got this angle here, and then I've got this angle here, and they share side XB. And it's 2 angles that are adjacent. Now, when you name an angle, we're going to name point A, point X, and point B as the vertex. As the angle. Notice that the vertex is always the center letter. And likewise, BXC is the name of the second one. So they are adjacent angles. Moving on. The next vocabulary word I want you to become familiar with is vertical angles. Vertical angles are formed by two intersecting lines that are opposite each other. So in this case, take a look at this, angle 1. Angle 1 is a vertical angle to angle 3. So this angle and this angle are vertical. Vertical angles have a unique situation in that vertical angles have exactly the same measure. They are congruent. Now, angle 2 and angle 4 are also vertical angles. So that would be this angle here, angle 2 and angle 4. When I put these little loops in there, the ones with the same number of little loops or arcs mean that they are congruent. So 2 and 4 both have 2 loops, so they are congruent. Angle 1 and angle 3 both have one arc or one little loop in there, so they are congruent. So congruent means that they have the same measure. Angles that have the same measure are congruent angles. Take a minute, pause the video if you need to write down those definitions. Okay, now let's talk about some special relationships between angles. We need to talk about the word supplementary. Supplementary means that the sum, that's adding, the sum of the measures of two angles is 180 degrees. That's the definition of supplementary. In our example here, I see that angle ABC is adjacent to angle CBD. Do you see that? They share a common side. They are adjacent, meaning next to. I also know that because this is a straight angle, that if I were to add together the measure of this angle plus the measure of this angle, it would equal a straight angle, or 180 degrees. If that means that these two angles, angle ABC and angle CBD, are supplementary. I can use that information to calculate the missing angle. So the angle I put a little arc in, how much must that be? Well, if the whole thing is 180, I can take 180 minus 120 and find out that the remaining measure is 60 degrees. Look at the next two. If the sum of the measures of two angles is 90 degrees, the angles are complementary. Please write down that definition. If the sum equals 90 degrees, they are complementary. So angle ABC and angle X are supplementary, and angle X and angle RQS are complementary. Let's look at which ones they're talking about. This is angle X, and this is angle RQS. Do you see that the angle X has the measure of 60 degrees? And angle RQS has the measure of 30 degrees. 60 plus 30 is 90. And two angles that with a measure of 90 degrees are said to be complementary. Let's look at this second or the last diagram. I'm going to circle it for you. This one right here. Let's recall that when you have a little square in the corner of an angle, that means that that is a right angle or a 90-degree angle. If RQS is 30 degrees, this angle right here, then what must be the measure of the missing angle PQR? Well, because there's that little box in the corner, it tells me that the sum is 90 degrees. They're complementary. So if one of them is 30, I can simply take 90 degrees minus 30 degrees and get the remainder of 60 degrees. The value of X, or this angle, is 60 degrees. All right, let's try some more. In the diagram at the left, let's find the measure of angle 1 if the measure of angle 4 is 135 degrees. The first thing I like to do is label what's given to me. I know that the M, meaning measure, of angle 4 is 135 degrees. If I know that that's 135 degrees, what other angle measure do I know? Well, I see that this is a straight line, and a straight line or a straight angle measures 180 degrees. So if this portion of the line is 135 degrees, then that means that these two angles are supplementary, meaning their sum is 180. So I can do a little math here. 180 minus 135 would give me the measure of angle 1. And so I know that this must be a 45-degree angle. The measure of angle 1 equals 45 degrees. Let's try another one. If the measure of angle 8 is 20 degrees, find the measures of angles 5, 6, and 7. The first thing you should do is jot down the 20 where 8 is. This is 20 degrees. Now, I like to look at this and say, I see that we have some vertical angles here. The measure of angle 8 and the measure of angle 6 are opposite each other. And we know that vertical angles are equal. So the first one I'm going to label is this one because it's opposite. The measure of angle 6 equals 20 degrees. How do I know? Because they are vertical angles. Vertical angles, and I'm actually going to use the congruent sign, which looks like this. This means congruent. And it's shortcut for writing congruent because vertical angles are congruent. All right, now I also see that I have some supplementary angles. So let's take a look here. This is a straight line. And I have angle 8, which is 20 degrees. So now let's look at angle 5. If angle 8 is 20 degrees, then angle 5 must be 180 degrees minus 20 degrees, which gives me 160 degrees to make that a straight angle. So the measure of angle 5 is equal to 160 degrees. How do I know that? Because it is supplementary to angle 8. Now you don't have to write all the reasons right now. I just want you to see it so that you can follow my logic. Now I'm going to erase all of this noise again, and I'm going to put what we know, which is this is 20. We now know this is angle 5 is 160, and I know that angle 6 is 20. Now we need to find angle 7. You have two ways. First of all, do you see that angle 5 and angle 7 are vertical angles? So measure of angle 7 is also 160 degrees because it's a vertical angle, is congruent, and in this case to the measure of angle 5. Or you could say that it's supplementary to angle 6. So you could take 180 minus 20, you would still get 160. So there's more than one method to doing this. Now let's talk about a transversal. A line that intersects the two other lines in different points is called a transversal. So here is my transversal. Write down the definition of transversal. Once you have a transversal, some pairs of angles are formed by transversals have special names. First of all, we have corresponding angles. You've heard of the word corresponding before. Corresponding means in the same relative location. Corresponding angles lie on the same side of the transversal. Same side of the transversal line and in corresponding positions. So some examples of corresponding angles are angle 1 and angle 5. So angle 1 and angle 5. Angle 3 and angle 7. Notice that they are both to the left of the transversal, and they're all in the same relative position. So meaning that there is a line that cuts through it. See the line that cuts through it? And 3 is below that line. Here's another line that cuts through that transversal purple line, and the 7 is below it. They're in the same relative position. In the same way, let's change my color here so you can see, angle 1 and angle 5 are both to the left of the purple line, to the left of the transversal, and in relation to the line, it is above it. 1 is above it, and 5 is above that line that cuts through it. So we would say those are corresponding angles. Now on the right side, we also have corresponding angles. Let's show those. Angle 2 is to the right of my purple line. So is angle 6. But so is angle 4 and angle 8. But angle 2 and angle 6 are both located above above the line that creates their angle. These two lines, angle M and angle L, they are above. Unlike angle 4 and angle 8, which are both below the line that creates them. The second line I want to talk to you about, or the second relationship, let's go back, is alternate interior angles. So here let's highlight our transversal again. And alternate interior are on the interior part of the two lines and on opposite sides of the transversal. So in this example, inside the two lines, do you see that here are the two lines? All of the angles that are on the interior would be these, 3, 4, 5, and 6. Those are inside the two lines. Okay, so now let's delete this again. Let's clear it so that I can focus for you specifically on, so here's our transversal. We're specifically dealing with the angles that are inside of these two orange lines, but they need to be on opposite sides of the transversal. So opposite sides would be 3 and 6. They are alternate interior angles, 3 and 6. Another pair of alternate interior angles would be 5 and 4. They're both interior, but they're on alternate sides of the transversal, that purple highlighted line. Now, when a transversal intersects two parallel lines, meaning if these two lines, the orange ones, if they would be parallel, we get a really unique situation where alternate interior angles are congruent. And corresponding angles would be congruent if the two orange lines are parallel. So let's take a look at what that looks like. Here are my two orange lines. Whoops, boy, I can't seem to draw. Here are my two orange lines, L and M, are parallel. And here is my transversal. Identify the following. First, identify the corresponding angles, then identify the alternate interior angles. Pause the video and see if you can find them on your own. Then continue the video when you're ready to compare your answers to mine. All right, so let's look back. Corresponding angles are on the same side and in the same position. So the same side and on the same position, I would say angle 8 is to the bottom of my transversal, and it's to the left of the orange line. Angle 6 is also to the bottom of the purple transversal, and it's to the left of the orange line. So angle 8 is congruent to angle 6. Let's find some more. I see that angle 1 is above the transversal, but to the left of the orange line. Angle 3 is also above the purple transversal and to the left of its orange line. So angle 1 is congruent to angle 3. But wait, there's more. How about angle 7? I'll use 3 lines this time. Angle 7 is below the purple transversal and to the right of my orange line. Angle 5 also meets those criteria of being below the transversal and to the right of its line. So they are corresponding angles because they are in the same location. So we're going to write angle 7 is congruent to, whoops, it's like a little similar sign and an equal sign combined, to angle 5. And the last one that I want to show you, this time I might just highlight them, angle 2 and angle 4 are also in the same relative position. All right, now let's try for, let's erase that, there we go. Okay, so my transversal was right here. Now I'm ready to identify alternate interior. Let's look back at the definition. Alternate interior are on the inside of the 2 orange lines, but on opposite sides of the transversal. So that being the case, let's make our lines orange again so that it's a little easier to tell. I know that they can only be, that we're only dealing with these lines, or these angles, 2, 3, 7, and 6, but they are an alternate interior. Alternate interior would mean that they are on opposite sides. So I would say 2 and 6 are alternate interior. So angle 2 is congruent to angle 6. Angle 7 and angle 3 are also congruent and are also alternate interior angles. All right, let's try another one. In this diagram, angle A is parallel to angle B. So I'm going to color those with my orange line. It is cut by a transversal. The transversal is this long line extending through. Name 4 pairs of congruent corresponding angles and 2 pairs of congruent alternate interior angles. I want you to pause the video and give this one a try on your own and continue when you're ready to compare your answers to mine. All right, let's give this a try. First of all, corresponding angles are in the same relative position and on the same side of your transversal. I see that 1 and 5 are both to the left of my transversal, and 1 and 5 are both above their orange line. So angle 1 is congruent to angle 5. Another angle with the similar properties are 4 and 8. 4 and 8 are both to the left of my transversal and below their orange line. So angle 4 is congruent to angle 8. We're really just identifying angles this lesson. Then let's do the same idea, but now let's point out on the right side of my transversal. Do you see that angle 2 is to the right of your transversal and above its orange line, just like angle 6? So angle 6 is congruent to angle 2. And lastly, angle 3 and angle 4 both are to the right of the transversal and below their orange line. angle 3 is congruent to angle 7. Now let's find alternate interior angles. That means that we are dealing with only the angles that are in between my orange lines. Let me quickly draw my transversal back in. So I'm only talking about interior, meaning 3, 4, 5, and 6. Now alternate means that they are on opposite sides of the transversal. That means to me that 3 and 5 are alternate interior angles. So angle 3 is congruent to angle 5. And then one more that we can find, 4 is interior and 6 is interior. And I see that 4 and 6 are opposite sides of it. So angle 4 is congruent to angle 6. Also, when you look at the angle measure, they even appear to be the same size, and that will always be true. All right, now let's give this a try. How does algebra play into this? Well, now that we know how to identify them, the angles, and we know the relationship between them as being congruent, I can see that the measure of angle 8, they are telling me is 2x plus 5. So they're not giving me the measure of angle 8 is 50 degrees. No, they're giving me a challenge. They're telling me that the measure of angle 8 is 2x plus 5. And the measure of angle 4 is x plus 10. And they want me to tell them what is the value of x. Well, the first thing that I am going to do is highlight my transversal. This is my transversal. I am also going to make my parallel lines again orange. Now this is easier for me to see. I see that the measure, that the measure of angle 8 is the same as the measure of angle 6. How do I know that? I know that because they are not complementary, good grief. They are corresponding angles, so they have the same measure. Measure of angle 6 is also 2x plus 5. They are both to the right of the transversal and above their orange line. I also know that angle 4 and angle 6 are the same measure. How do I know that? Because they are vertical angles. That means that x plus 10 is equal to 2x plus 5. Now I have an algebraic equation that I can solve. I subtract x from both sides. 10 equals x plus 5. I subtract 5 from both sides, and I get 5 equals x. The value of x is 5. I can even substitute that back in to know that the measure of angle 4 is 15, and the measure of angle 6, by putting a 5 in for x, would mean also 15, 2x plus 5. Now that's not really drawn to scale, is it? All right, so let's give this one a try. I want you to pause the video to try to find an equation to find the value of x. Once you've found the value of x, substitute it into the expressions to give me the measure of angle TAV, the measure of TAN, and the measure of angle DNK. Continue the video when you're ready to compare your answers to mine. I would start off by highlighting my transversal and my parallel lines, and I'm making them the same colors, orange and that purple color. One thing that I know is that the angle VAT, that is labeled 2x plus 12, is also the measure of this angle here, 2x plus 12, because this angle and this angle are corresponding angles. Now I know that if I add together this angle and this angle, that it's going to equal 180 degrees. 2x plus 12 plus 6x plus 16 equals 180 degrees because they are supplementary angles. Now I can solve this algebraic equation. The first thing I'm going to do is combine my like terms. I'm going to use the commutative property to rearrange the numbers so I can put my like terms next to each other. 2x plus 6x is 8x. 12 plus 16 is 28. I'm going to now solve for x by using inverse operations. I subtract 28 from both sides. And I get 92. Ooh, wait a minute, did I do that right? Let's just double check here quick. Oops, how about if we get 192? And so divide both sides by 8. 192 divided by 8. And I get x equals 24. Now if I know x is 24, first I want to find TAV. TAV is right here. TAV, which is 2x plus 12. So 2 times 24 plus 12. 2 times 24 is 48 plus 12 gives me 60. This is a 60-degree angle. Now let's find TAN. TAN. Let me see. Find it here. TAN. That is supplementary. So I can take 180 minus 60 and I get 120 degrees for TAN. Then DNK. DNK is this angle down here, which is represented by 6x plus 16. So I can do 6 times 24 6 times 24 plus 16. So 6 times 24 is 144 plus 16 gives me 160, 100.